Good morning. My name is Martín Rausch, and together with my partner, Maximiliano Lódolo, we are going to present the skill integration project of English 2. This project is titled CO2 capture in large industries, the post-combustion method. Maximiliano and I are third-year students of electromechanical engineering at the Universidad Tecnológica Nacional, Facultad Regional Paraná. Currently, the CO2 emissions are a main problem in industries that need burning fuel in different processes and make CO2 the main greenhouse gas. This problem is related to Sustainable Development Goals 13, Climate Action to 2030 Agenda. And has been a cause for concern for several years. One possibility to attack this problem is CO2 capture. In this paper, we describe the principal methods, make a comparison between them, and analyze the possibility to apply on large scale. Now, let's look at the organization map of this presentation. First, we will describe the problem and its impacts on the environment. Then, it shows the problem specifically that we confront, and CO2 capture is presented as a possible solution. And the principal post-combustion capture methods are presented that are chemical absorption, physical absorption, adsorption, and membrane separation. In addition, we do an analysis of advantages and disadvantages between methods. Finally, we performed a feasibility analysis to apply this method.
Hello, my name is Maximiliano, and now I'm going to describe the problem addressed in this presentation. As mentioned above, CO2 emissions have an impact on the environment. But what is the impact? Greenhouse gases allow the Earth to absorb energy from the sun, but make it difficult for the energy to be radiated into space, which causes an increase in temperature on the planet, raising sea levels, among others. These problems are due to natural causes, but also to the hand of man, since these greenhouse gases are emitted to a large extent by industrial process. And the most important gas is carbon dioxide. This is due to the incessant burning of fossil fuels, which emit CO2 into the environment. Furthermore, the main source of emissions is the energy sector, since it mainly uses coal as fuel. A possible solution to this problem is CO2 capture. Below are the different methods that exist, which are pre-combustion method, oxy-combustion method, and a post-combustion method, as seen in the diagram. Oxy-combustion is mainly used experimentally because it is the most complicated to apply. Pre-combustion consists of isolating and trapping carbon before it is burned, and the post-combustion method, which is currently the most used, consists of capturing carbon after combustion. In this paper, we focus on the last method and its application.
Within the post-combustion techniques, we can find chemical absorption, physical absorption, and membrane separation that described below. Chemical absorption use chemical solvents in its process. For example, monoethanolamine, diethanolamine, and methyl diethanolamine. And they are used in aqueous solution. This process is done in two steps. First, the CO2 is captured through reaction, and a rich solution in it and a poor solution are obtained. In the second step, the rich solution is treated and the poor solution is returned to the first step. The parameters to consider in this process are combustion gases. It determines the size of the absorption tower, CO2 concentration, limits the amount of solvents, elimination of CO2. CO2 removal can be between 80 and 95%. Solvent flow, the greater the solvent flow, the greater the equipment associated with it. And energy requirements, all the energy consumed in this process, and others.
Another technique is physical absorption, whose process is based on the use of a chemically inert solvent to physically absorb the CO2, which is dissolved in it. The solvent can then be recovered by drainage and CO2 collected for storage. As this method achieves great results at high pressures and concentrations. One application is, for example, in the coal gasification process.
The absorption method uses a solid surface to remove carbon dioxide from a mixture. It's based on two processes, an absorption process and an regeneration process that operates cyclically. This method can be done physically or chemically. In physical absorption, the process is based on ability of the solid to trap gases at high pressure in their pores. On the other hand, in chemical process, the gases react with the surface of absorption of the absorber and generate chemical bonds. The main materials used in this process are zeolites, activated carbon, metallic organic structures, and covalent organic structures.
The latest technique is membrane separation, which is a relatively new technology for separating gases. Its operation is based on the ability of a membrane to allow the passage of only selected chemical species. The main characteristics of membranes are their permeability, that is the capacity of the substance that can be transported, and their selectivity, that is the ability to separate only some species. Therefore, the ideal membrane will be one that only allows the passage of CO2. There are two types of membranes. polymeric membrane and inorganic membranes. Polymeric ones have the lowest production cost, but have a low selectivity. And inorganic membrane obtain high selectivity, but are more difficult to produce, which make them more expensive.
Now is the time to do a pros and cons analysis of afterburning method. First, chemical absorption has the advantage of capturing CO2 in a low partial pressure flow. In addition, has the high capture capacity and is the best suited to industrial application. The disadvantages are that need large amounts of energy and the solvents are corrosive. Physical absorption has the advantage of allowing simultaneous removal of CO2 with other acid gases and offer high efficiency. Its disadvantage is that need high pressures and concentration to achieve high greatest efficiency. Absorption is versatile since it can operate at more than 500 degrees and can reach efficiency of 99% if solids are used as solvents. The disadvantage that has to do with the energy consumption because it's necessary to compress the gas to treat again. Finally, membrane separation allows for high selectivity, that is a higher percentage of CO2 capture. The disadvantage of this method are that need high pressure variation between sides of the membrane, high partial pressure of CO2 in the gas, and the membranes are not economical.
As a last point, we do an economic study. According to recently carried out studies, CO2 capture caused an increase in the cost of energy production. For example, in natural gas power plants, the cost increased between 64% and 100% compared to plants without capture. In coal plants, capture represents an increase between 44% and 87%. In addition to this industrial application, there are currently plants that are dedicated solely to CO2 capture, as is the case of Orca. We think it is important to mention it because they are another great bet on the future. In conclusion, it is important to develop renewable energies on a large scale to stop using fossil fuels. Furthermore, it is urgent to address the energy sector because it is the main CO2 emitter. Carbon capture is a good option to develop in the coming year to meet the objectives of the 2030 agenda. An advantage of CO2 capture is that it offers different methods and industries can choose the type that best suits them. Finally, as well as industries, there must also be a commitment for governments to take the necessary measures in relation to caring for the environment.
These are the references utilized in the presentation and are available to consult. Thank you for your attention.
Thank you.
Thank you, Martín and Maximiliano. Very good job.